So, before we get into linked lists, I want to kind of refresh your memory on what pointers are, because linked lists use a lot of pointers. Um, and so let's go ahead and make a new project. I'm going to go ahead and call this one pointers. Then we hit OK. Let's go next. Do console application. I'm going to start off with an empty one. I'm going to go ahead and hit finish. So let's go ahead and right click here and go to add, and we're just going to add a new item. It's a C++ file, and I'm going to name it pointers. And then inside of here, I'm just going to include IOStream. And I know this might seem a bit redundant, but if you're like me, I often just need to continuously rote rehearse or redo over and over again sort of the things I'm coding, or I'm sorry, I'm doing. So let's throw our main in there. So, um, so you probably heard about pointers, right? You're like, well, what is a pointer, right? And so pointers essentially access memory. And in the past, when we used to need to optimize the best that we can, we'd always be sort of pointing to a memory address and sort of like instead of pointing to an index, or if we use a dictionary, if you're familiar with those, we have an ID. So um, it's really more for optimization. Nowadays, it's sort of actually an arguable point whether pointers are faster than even just, the modern compilers are pretty quick. And so if you're indexing an array versus a pointer, but it's a good idea to look at it, especially because we're moving into the point where we're going to Unreal C++ coding, and you might be looking at some legacy code where they're strictly using pointers. Um, so I just want to make you aware of that debate. So let's jump right in. So let's go ahead and code something up. So I'm going to write float data. I'm going to make that equal to 5.0, and then I'm going to console output data. Okay, and then I'm going to hit Control F5. Let's close that out. Build that anyway. Now you can see here that we printed 5 to the screen, right? Now, how do we, what we have here is we have a data, we have a variable called data that's of this type float and it's holding 5.0. But say we put a little, the and symbol in front of data here, and I go ahead and I rerun this. We get something completely different. And what it is this stands for the memory address of whatever data is. So we get this hexadecimal value. So we don't necessarily have a hexadecimal data type. So in order to point to that memory address, we have to use pointers. So let's go ahead and jump into that. So the way that you can create a variable that can point to a specific memory address is you have to give it the same data type as the data that's going to be stored. So we're storing a float value here. And so what I can do is I can name it pretty much anything I want as long as it's within the context. So I'm going to name this data pointer, and I'm going to make it equal. And actually what you do before that is you have to put an asterisk here indicating that this data pointer is a pointer, right? So what I can do either on the same line or the next line is I can just say data pointer. I'm doing this to sort of show you that you don't need, once you declare it there, you don't have to put the asterisk again. It's C++ knows that this is a pointer and that what it's going to store is whatever the memory address is. So what I want to do is I want to save the memory address of data, and then I'll copy this line again, and instead of having the um, the and symbol with data here, I'm just going to console output data pointer. So I'm going to go ahead and hit Control F5 to run this. And you can see I get the exact same pointer or memory pointer. And you're going to see the practical application behind pointers in probably the next video where I talk about linked lists and pointing to memory. And again, just to sort of reiterate, like um, in the past, the biggest argument to use pointers versus whether to access indexing is when hardware memory was low, it was faster to optimize your code using pointers.